You still there, Steve?
Yes.
Okay, perfect.
All right, and we'll get started in about a minute. All right, I guess it's about that time. I'm assuming everyone can hear me. Brandon, am I good?
Yep.
And you can see the chapter deck up on the screen, hopefully. All right. Hey, everybody. This is Mark Swafford, and I want to welcome you to the DBA Fundamentals virtual chapter meeting for September 2014. Today's presentation is entitled Treating Tables Like Legos, Partitioning Basics, and it's being presented by Brandon Leach. I'll hand things off over to Brandon here in just a few minutes, but I want to tell you a little bit about what's going on here at the Fundamentals virtual chapter, PASS in general, and give you a tip or two about the virtual meetings and themselves, and then I'll introduce Brandon. So first, you can put all your questions in the Q&A field on your screen, and if you have any technical issues, please raise your hand using the icon that looks like a hand. You can also send me a chat message if you have any technical questions. When you put a question in the question area on your screen, Brandon will have the opportunity of whether he wants to kind of field questions as we go, or he may want to answer them all at the end. Completely up to him. All the presenters are a little bit different. This session will be recorded, and the broadcast for this session will be available within about a week at the most, on the DBA Fundamentals website. And you'll just scroll to you'll click the archive tab, and you'll get a list there of all of our most recent broadcasts. So if you don't catch the whole presentation, or you get disconnected, if you have to go to a meeting, whatever, you can check back in about a week and navigate to www.fundamentals.sequelpass.org, and you can see our link to the website up on your screen about halfway down. So my name is Mark Swafford. I'm the president of the DBA Fundamentals virtual chapter. Feel free at any time to shoot me an email. My contact information is on our website in the About Us tab. Real quick, I just want to go through the PASS community news for September. And the hot topic right now is the PASS Summit. Hopefully most of you, if not all of you, plan on attending. If you've never attended one, I have to say it's probably, in my opinion, the most fun I've had at a SQL event in my career. I mean, there are thousands of people there, thousands of companies, people from all over the world fly in to attend the summit. This year it's in Seattle, and you'll see a code, or you should see a code on your screen at the bottom. It says register using VCSUM09, and that'll save you $150 when you register. So it's kind of cool, and the $150 discount will last until September 26th. So if you've never attended the past summit, I encourage you to check out the sneak peek that we're running. It's the sneak peek of the past summit 2014 that occurs on September 9th. And it's 24 free SQL Server and BI training webcasts. It's just a slew of webcasts. It'll kind of give you a little taste of the kind of content you will see at the summit. And if you want to register, just go to 24hoursofpass.com. And we have upcoming SQL Saturday events. Another type of SQL event I love to go to is SQL Saturdays, just all day, jam-packed SQL training events from early in the morning until mid-afternoon. They usually serve lunch, I think for a small fee, or at least the ones around here do. So if you're in the Raleigh or Kansas City area or Denver, or you can see Paris up there, Kiev, Dublin, they're having them now all over the world. So I encourage you to check those out. If you've never been to one, it's pretty fun. And it gets you kind of plugged into the PASS community, if you will. It's just a neat event to go to. So we also have the PASS Volunteer Awards, and it's the Volunteer Award is someone that has just given a lot of themselves to the SQL Server community, and you can nominate someone for the PASS Award at volunteer recognition at SQLPass.org. And I encourage you to also stay involved. Being involved in PASS has just been not only one of the highlights of my career, but it's also taught me a lot, and it puts you in a network of people that are highly well respected. I mean, it's been a learning experience too. So it's really taken my SQL ability, being a DBA, database developer, to the next level. So if you've never been involved in PASS, I would highly recommend it. And all of the PASS chapters are always in need of speakers. And there are some chapters too looking for volunteers for other things as well. So you can always go to the virtual chapters website or independent website and see what the need is there. All right, so that's kind of the housekeeping that I have. I'm going to go ahead and make Brandon the presenter now, and hopefully I won't kick everyone off the webcast. That would kind of stink. And then
all right, you should all see my horrific background.
Yeah, so let me. So today we're going to treating tables like Legos, partitioning basics. So partitioning allows us to isolate the parts of our table, small chunks, called partitions. So in turn, these partitions allow us to do some really cool tricks for manageability and performance. In this session, we'll look at the concepts surrounding partition and how we can apply them. So Brandon's a veteran IT professional in the healthcare industry. He originally started out as a career as a web developer and fell in love with SQL from there. So database development and administration. Currently, he manages 100-plus SQL servers for Network Health in Medford, Mass. And he works closely with the development, infrastructure, and management in and out of IT to make sure that the needs of the business and its future goals are met. And he's the chief organizer for SQL Saturday in Providence, Rhode Island. So Brandon's plugged in, and Brandon's also given back to the community, like I mentioned before. I'm sure he can attest to how fulfilling it is. But at this point, I've taken all of your time that I need, and I'm going to go ahead and turn it over to Brandon. I appreciate you being here, man.
All right. Can everyone see my screen?
Introduction to Partitioning in SQL Server. I can see it.
Can I go? Yep. Perfect. So, obviously, a little bit about me. As was just mentioned, I am a senior DBA here at Network Health. I can be found on Twitter at SQL Server Nerd. Please look me up. I'd love to chat with everyone. Does anyone know a little site called the Daily WTF? It's, if you don't, it is kind of an IT horrors comedy site. I'm actually one of the admins on the forum responsible for making sure that people don't post information they shouldn't. As for the Providence, I ran that for 2 years. This year it's actually being organized by one of my friends, John Miner, who runs the local user group down there in Providence. The next date for that, if you are in the area, is October 18th. So, has anyone here wanted to be able to perform maintenance on just part of a table? How about migrating data in and out of tables, say from staging tables into production tables in milliseconds? Or spread your tables over different, or parts of your tables over different tiers of storage? What about anyone have any issues with locking? Table locks becoming a problem. Well, SQL Server provides partitioning as a way to kind of handle all of this down at the individual table level. So partitioning is the concept of taking the table, splitting it up into chunks, assigning individual rows to those different chunks. So it's kind of like building out, your Lego constructions. I don't know if anyone's ever been to to one of the Legoland Discovery Centers. There's actually one right down the street from my office. In fact, it's about a 5-minute walk. And you can go in there, you can just build things all day long. They have workshops on building things and all sorts of fun stuff. But if we stop thinking about tables as one object and think of it as multiple objects that have come together, it gives us a lot more flexibility. Now, even though a lot of the benefits of partitioning come from a performance standpoint, it's considered a management feature. And the reason for that is a lot of times when you implement partitioning, it's because you're trying to get a finer grain of control over your data and the access to that data. Now, as we go through, please, as was mentioned, please put your questions in the chat window, and I will try to stop periodically to address those as we go on. I'll also have space at the end for any additional questions. So, we've already discussed some of the ways in which it can help from a management perspective, but from a performance perspective, there are things that partitioning allows you to do. There's the concept of partition elimination that can come into play, where SQL Server says, well, I don't even need to look at that part of the table. I just need to look at these partitions. And so it can help reduce a lot of I/O. This is also great when combined with joins. For equivalent joins, when they're partitioned, the two tables are partitioned on the same column, it will just join those partitions. It will ignore other parts of the table or other partitions of both tables that don't need to be taken into account. Also, one of the things I'm going to do here is I'm actually going to move 1,000,000 rows out of a table in a millisecond. So, horizontal versus vertical partitioning. Two very distinct concepts. People get these confused all the time. I get these confused all the time. I've seen MCMs get this confused. So when we talk about vertical partitioning is essentially splitting out columns. So, example, a 400-column table, it's not going to perform very well. Without getting into the internals, there's a thing called page density. And the amount of rows you can fit on a page, the more the better. Well, vertical partitioning says, okay, these columns, we don't really need them. At least not most of the time. So we're going to split those out into a separate table. Now, horizontal partitioning partitions based on rows. And this is what we're really going to talk about today. So the idea is certain rows will go one place, other rows will go another. And we have two techniques to do this. Partitioning itself was introduced in SQL Server 2005. Prior to that, we had to do this partition view thing. And the idea behind that was we'd actually take and create multiple tables. Say we needed data throughout an entire year. What we would do is we would create a table for each month. Then we would put constraints on those tables, check constraints specifically. And what we would do is we would essentially define those constraints to say it can only contain this specific month, so only November's data. Well, SQL Server is actually smart enough to read those constraints when it generates an execution plan. It'll take them into account. So when we would layer a view on top of that, using a union statement to combine all the different tables into one super table, or at least as far as the query was concerned, that would allow us to query all the data as if it was all one table, even though under the hood it's really multiple tables. And I'm going to show an example of this. It also, because of those check constraints, we get that partition elimination I mentioned. And partition views are a great way of demonstrating partition elimination. So keep in mind one caveat, though. The constraints have to be trusted. If they're not trusted, SQL Server will not use them to generate an execution plan. So I am going to exit out of this, and I am going to bring up a quick demo. Everyone can see Management Studio, I assume. Please let me know if that's not the case. So I have a bit of a sample database here. I have two schemas in that, one for partition tables themselves and one for partition views. Now, over here, I have a constraint on data on the table called current month's orders. Just going to show you what that looks like. This constraint, as you should be able to see, and I don't know if you can see zoom it, so let me know if that makes a difference. As you can see, this can only contain data from the 2nd of November, 2013 and greater. So right now it has November and December, so I know it's not actually a current month. But it gets the point across, very simple constraint. If I go back, I believe it is this window. Let me show you what happens if I just select all from this view that I've created. if I do that and I look at the execution plan, we will see that it did a table scan of current month orders, and it also did a table scan of orders archive table, both in the PV schema. It had to join the tables. And let me show you the statement for the view itself, because this guy is really kind of simple. Literally, I'm just doing a union. Now, union versus union all, it depends. I try to use union when I don't need duplicates. Usually, you're not going to have a situation where you've got constraints that allow, the same row in one versus the same row in another table. So, when using partition views, you can usually get away with union. So, back to this guy. I'm going to add in the where clause now. And what I want to show you is that whereas before we have it querying both tables, it's only going to query the one now. So, as you can see, I queried the same view, but I got a very different execution plan. It literally just scanned current month orders. It did not touch orders archive. Now, someone also asked an interesting question a few months back. They said, what if the range being queried, there are no tables that contain that data, or as defined by the constraints? So you'll notice before, in the constraint definition, I had it doing 2, the second of the month. I did that intentionally, because when I query the 1st of November 2013, that's outside of the bounds of the constraint on either table, and obviously returns no rows. Well, here we see it didn't even bother to touch either table. Really efficient on the number of reads there. It just didn't do anything. And the idea is, why should SQL have to go and why should SQL Server have to go and touch these tables if it knows they don't contain the data? So let me actually go to 10 October and run it. And you'll see now we're touching orders archive, but we're not touching current month's orders. So, do we have any questions at this point before we dig into table partitioning itself? If you do, please type them up. Also, just want to make sure that everyone still hears me.
Yeah, you sound pretty good.
Awesome.
And it looks like in the questions box there are a few questions there. Do you want me to read them out to you?
Absolutely.
Yeah, it says, what does partition aligned indexes do?
The saying is, there are good questions, but a great question is one you have a slide for.
Awesome.
So I will actually get to that, yes. It's a little further as I explain kind of the process and what's involved in partitioning. But the long story short is, when you have a non-clustered index and you build it on the same partition scheme as your table, it is said to be aligned. And I'll talk about that more and explain what all that terminology means.
Okay, and then we had We had one other question, it looks like. So it says, I wanted to scan the query plans to find those partition tables that are not using partition elimination. So I want to find the number of partitions used. Is that something that you can
The
do?
number of as in find the number of partitions for a table, or how many partitions it has?
Correct.
Because we
I'm
can do
assuming
that.
correct.
There's we can actually see a whole lot of data through the DMVs. And there are other things you can do too. Like if you wanted to go even further, we could actually run a query and have it, for every row, have it return what partition it's on. But you're gonna have to use a few tricks for that one. But I have scripts if you want to see exactly what partition a row lives on. In fact, it'll show you what page, all the way down into the internals. But
Okay, so
as far as finding out
he kind of
go
clarified
ahead.
that. He kind of clarified that. It just says it was to find those plans that are not properly using partition elimination, I guess.
Well, you'd have to pull the partitions out of, or the plans out of cache, and you would essentially have to search through the XML output for a specific partition ID to see if that's happening. Usually, if you look at it graphically, like if you'll have some information here that'll come up, and I'll show you how to find that through the tooltip. But that'll be a bit down the road. But yes, I will show you how to do it through the tooltip. I don't have a script written to actually find plans that are using partitioning.
Gotcha. All right, and I think there are some more questions coming in, but for the sake of time, if you want to move forward, we can definitely hit some you said at the end if we have time, correct?
Yeah, I'll make sure that we have some time.
Awesome.
So, all right. We have gone over partition views. So let's talk about table partitioning itself. As I said, it was introduced in SQL Server 2005. It is an enterprise-only feature. And I need to call that out explicitly because if you do not have enterprise, you cannot use table partitioning itself. You can still do the partitioned views. Another thing is, partition views, it's not as transparent to the queries. As in, it's more visible to them, I should say. Well, table partitioning, your developers don't necessarily need to know that the table's partitioned. They can certainly take advantage of some things if they do, but you can implement partitioning and they are none the wiser. It's a lot more complex. We have to talk about things like partition schemes, partition functions, file groups, data files. There's a lot more that we have to kind of pay attention to. So this slide just provides a basic overview of kind of how it all works through the stack. IAM chains, you don't really need to know that, but just understand that each partition is a separate object. And the table itself is the sum of those objects after they've been combined. So there's another level of locking too that comes into play. When you partition your table, locks can escalate to partition locks before they escalate to table locks. This could be a good thing because, why lock the entire table when you only need to maybe get at a section of it? And this will all happen underneath the hood. You won't even be aware unless you go looking for it that this is happening. So in order to talk about the parts, we really need to talk about data files. We need to start at the bottom. So everyone knows what these are. They're the MDF and NDF files on your hard disk. All the objects are stored in one or more of these files. We can have multiple files within what's called a file group. If that's the case, SQL Server will spread the I/O operations. It'll round robin them. So as it adds data, it'll send it to file 1, then file 2, then file 3, then file 4 within the same file group. It's going to try to keep them evenly sized. So if you have one file that's a lot smaller than the others, that file is going to get all the I/O and it's going to become a hotspot. But in this way, we're able to kind of spread all of that around. File groups are when we build objects. When we build tables, we assign them to we build them on a file group. And you'll notice if you script out your objects at the bottom of the table definition, it'll say on primary a lot of times. Primary is the file group. It's when you create a database, it's going to create a default file group. There are things you can do when you're partitioning. You're going to be creating multiple file groups. It's highly likely that you're going to create multiple file groups. So, partition functions. Now we're starting to build up. We're getting further into the meat and potatoes. So we have to have some way of saying, which row goes where. How are we going to divide this data? So the partition function essentially creates an algorithm to assign these rows to different buckets. So essentially what we're doing is we're going to define boundaries for those buckets. So the most common thing to partition on is date. In fact, it's somewhat rare not to partition on date. Well, in this case, that date is known as the partition key. And we have to specify boundaries. And when we specify those boundaries, we have to determine where that boundary falls. Because if you're just specifying boundaries, does the boundary go into the previous bucket or into the next bucket? And that's known as range left or range right. If you're using dates, which most people are, you are going to use range right because you're going to define based on the first of the month as opposed to trying to figure out what the last day of every month is. Let me actually show you a partition function. So what I've highlighted here is a very simple partition function. This is what they're going to look like most of the time. In this case, we have several buckets, one for each month of the year, specifically 2013. We're also telling it you'll notice after the create partition function order date range PF, in parentheses, a type, specifically date. We're saying these boundaries are dates. And we're saying that each boundary is going to go into the next bucket. So the first bucket will contain 1/1/2013, then the next month's bucket, then the third, and so on and so on. Partition functions are real easy to. So the next thing we have to take into account is partition schemes, because if we've got a function, we need some way to define what file groups hold each bucket. Now, this is where we require a little more thinking, because there are reasons to send every partition to the same bucket, and there are reasons to spread them out. So if we want to speed up our ETL processes, we've got staging tables, and we want to be able to move that data really fast into those production tables. We need to make sure that the partitions are within the same file group. And we can do that with the shortcut all2. Now, if we want to split things out on different tiers of storage, then we're going to send things to different file groups. Maybe have the older data on 10,000 RPM disk. Maybe have the newer data on the real new data on SSD if we can. Or, 1,500 RPM disk. The point is, the partition scheme is going to play a key role in your strategy. The partition function, well, that's just saying how we'll break up the data. This is saying how we're going to store that data. So, someone asked about aligned indexes. We'll get to that in a moment. I just want to take another quick pause for questions. Do we have another batch in the Q&A? Because I can't actually see the Q&A.
Oh, okay. So can you hear me?
Yep.
So what's the difference between a partition view and a normal view?
Well, a partition view is essentially a view. It's really, we're using, the view itself is normal, there's no difference. What does make a difference is the constraints on those tables. It's really, we're giving the optimizer more information so that it generates a better plan.
Alrighty, and is there an impact on replication?
Replication should be pretty much unaffected by partitioning. I've never combined the two, so I would want to test that first. But partition tables work under the hood. So, the subscriber isn't going to know necessarily the actual underlying storage, so I don't think there would be an effect. But I could definitely set up a test, actually, and do a blog post on that if you'd like.
All right. Can you give a brief example of a partitioning strategy that doesn't involve dates?
That doesn't involve what? I missed that last part.
Doesn't involve dates.
Dates. Well, say, for example, you have a multi-tenant database. You've got several clients. They all have their own data. You might partition based on clients so that, you know that client is never going, you never want them to read another client's data. Or they shouldn't have to. You don't want another client's data to slow them down. You might partition on clients in that case.
All right. So if you're constantly adding to the table with new data, how do you set up the partition function?
Ah, that's a very good question. And that is an advanced topic. I don't think we're actually going to get to it, but let me provide an explanation. So you can, once you've partitioned a table, you can create new partitions. In fact, what is very common is you can actually switch partitions in and out of tables. So the basic idea is you create a new table, leave it as a heap, dump all your data in it. You know, get the benefits of a heap, really fast inserts. Then apply all the same indexes to that new table, at which point you can do an alter table switch statement and tell it that that staging table you created is now actually a partition of this other table. This is often used with a technique called sliding windows, which, based on our time, I don't actually think we're going to get to today. It is now 11:09 your time, correct?
Central time, yeah.
Yeah. Okay.
So
But I will show you how to switch data in and out of tables.
okay. So and you may have just answered this other question then with that response, and then the question was, is it possible to apply a partition after the table has been created and already contains data?
Yep. You can actually you can do the reverse too. You can remove a partition, which is great if you ever wanted to truncate just part of a table. Pop the partition off and truncate that, or just drop it. You can literally do a million row delete or a billion row delete in a couple milliseconds doing that. Really fast.
Great. So how many you let me know when you're going to move on, and I'll just keep asking questions until you're at that point. Is that do you want to go now? Or?
Yeah, it is 10 past 12. We've got about 20 minutes left.
Yep.
It looks like. Okay, so then I'll jump back in because I want to show a couple quick demos, or quick things. So I didn't show what a partition scheme looked like. So in this case, I'm sending everything to the primary file group. That's shortcut syntax. I could also, if I go down and script this out, not under storage. Under the storage tab in your database is where you'll find this stuff. And I do partition scheme. I want to show you what that's a shortcut for. Because when we do all2, we're sending every partition to the one place. So create partition scheme, and I need to, because I can't actually see that with the thing. There you see, it put, instead of all to primary, it put primary, 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 etc. ad nauseum. So all2 is a great shortcut. Let me go back, and we will get into the rest of this in a little bit. So, aligned indexes. As I mentioned before, these are indexes that are built on the same partition scheme. So when you create your table or your index, you do on and then specify the name of the partition scheme, as well as which column is going to be the partitioning key. This is going to allow you, or allow SQL Server to actually split the data up into separate buckets. The cool thing about partitioned indexes is also how many, I'm sure a bunch of you have had at some point a situation where an index rebuild or reorg was taking forever. Well, for those of you with that issue, you can actually just rebuild or reorg parts of a partitioned index. We can just specify a partition or a set of partitions. And this, if you've got really tight windows, this can be a great option. If you're using Ola Hallengren scripts, which I highly recommend, those actually take this into account. And they will go through a calculation to determine, okay, I just need to reorganize these partitions, but those partitions need to be rebuilt, and those other ones don't need to be touched. This can really save you a lot of time. Highly recommend it. You can also rebuild just a partition of a table. Basically, it allows you to do a lot more than you would with just the standard table. And every table already has one partition. You can already add a second partition if you want. But you might as well just rebuild it on a partition scheme and have it break the data down into the buckets you want. So let's actually look at creating a partition table here, because I've already actually built this out. So if I want to create a clustered index, right? Say I've got a table. It's got a clustered index. I want to rebuild that table on that partition scheme. Here you can see we're creating the clustered index, we're dropping the existing index, and we're building it on this partition scheme. Now that's actually going to cause the data to move. For example, if it needs to set, if that partition scheme says different file groups, stuff is going to different file groups. So it is that simple. And the same, in fact, we're doing an index there, but because it's the clustered index, it is, in fact, the table. Now, I'm actually going to truncate a table. Orders archive from the part table schema. So one of the problems with the count statement is it has to run through the entire table. I'm actually going to show you a workaround for that. I believe I've got it down here because we're going to need that for some demos coming up. But we'll get to that in a moment. So, also there's a bunch of information about partition stats, etc. So let's actually look at some of that. So the sysdar partitions table, the system table, actually has some great stuff in it. We have, for all our tables here, let's go find one that is partitioned. I believe, aha. So you see how orders archive here has multiple entries. Each of these is a partition. It tells you the ID, tells you the objects it's a part of, it tells you what index that's a part of, and its partition number. It also tells you the number of rows in that partition, as well as what data compression setting you have. So we can actually group on rows, or sorry, sum on the rows and group on the table. So once we know the object ID, we can sum the rows. We can get an quote-unquote approximate idea of how many rows we have in the table without logging. Now, I've never seen this not be accurate, but Microsoft defines it as an approximate number of rows. So don't depend on it. Also, we can, as you can see here, we can compress different partitions. So we could use page compression or row compression. For example, we might want to page compress our much older data and only row compress some of the newer data. So let me find in my little script here, I have a count that is done, I believe, here we are. So this is a much faster way of getting an approximate value of the number of rows per partition. As you can see, order 10 million, or orders 10 million. And you'll notice I'll have two orders in here because I didn't take into account the schema. But if I bring this down, let's go into the fun stuff to make sure we have time for questions. Because I really want to split that table out for you, or rather move a million rows real quick. So in terms of partitioning management, I've already covered some of this. We can switch data in and out. There are some caveats to that. The tables that you're switching in and out of must have the exact same design, meaning the same indexes, etc. Same constraint. Everything should be identical. We can also merge partitions together or split them apart. Again, all this stuff we're doing, these are metadata operations. We are actually taking and hooking up via the IAM chains and assigning pages to different objects instead of actually taking the data out and putting them on new pages. This is why it's so fast. We can also split partition, well, I mentioned splitting partitions up. We do this by defining a new range. We alter our partition function and we add a range in. This is going to cause it to split. Same with the merge statement. We alter the partition function and we add two partitions together. As long as these partitions are in the same file group, this will be really fast. Then there's the alter table switch statement, which is the only one that's not alter partition function. It's alter table. Again, same constraints. They must be in the same file group. Both tables have to already exist. Also, if you're transferring into a partition table, the partition itself that you're transferring into has to be empty. And also, if you're transferring out of one table into another, it has to be empty. And non-partition tables have to be empty. It's a very finicky, shall we say. So, because I want to leave plenty of time, let's go to the switch demo. So the first thing I want to do is I show you how fast it was to get the numbers there. It took 0 seconds. Let me show you what happens if I try to count out of that. Well, in this case, it was relatively quick. Oftentimes, though, select count star can take a lot longer. So now that we've truncated, we verify that our parttable.orders archive has 0 rows, whereas this one has 10 million. So what we're actually going to do, because I have actually placed already, I've already partitioned both tables, I'm going to take the third partition out of orders and make it the third partition of orders archived. This is going to move about 1,000,000 rows. And we're already done. Now, if you remember, orders archive had 0 rows in it. Now we've got 767,000 rows in it. And also, orders has less than the 10 million it had. So we've actually moved that data back. We could do this multiple times. We could do 5. Let's move partition 5 as well. Right? Again, now we've got even less in the orders table and even more in the orders archive. So let's try something quickly. I'm going to show you an error. Select top 1 star into temp from orders. Now this will create an unpartitioned table with 1 record in it. Oh, sorry, I forgot the part table dot orders. So we got 1 row. Now let's truncate table temp. Let's copy this, and we're going to switch that into, we'll take partition 6, and this will be partition 1 of temp. Because remember, temp is not an actual partition table. And let's see what happens. You'll notice, as we wanted, we got an error there. But unlike many other things in SQL Server, this one actually gives a really useful error message. Basically, it's saying that it didn't do it because the clustered index from parttable.orders does not exist. So if I go up to where that clustered index is defined, up here, and I copy that, we can actually add that. So because it doesn't exist, we don't need the drop existing. Let's just make this this will be real quick. There we go. So now let's see what happens when we run this again. We get a different message. So let's eliminate this guy now. I just want you to see all the kind of nuances of this. As you can see, it's very, very picky. So, yeah, everything has to be exact. Let's try this. So we're going to rebuild that, this time on primary. And this is going to be temp again. So we are once again going to rebuild that index. And try it again. Yet they fail now because they're no longer identical. So as you can see, everything has to be in order. So what do we do with this quickly? When we want to do our ETL loads, we create a new table. We dump all our stuff in there. We then apply our indexes. We make sure everything matches, constraints, foreign keys, everything has to match. There's one little difference, you're going to get one of these error messages. And as you've just seen, they're a pain. But once we do that, we can reduce the time our ETL loads take considerably. Okay, so thank you for coming. Let us move on to questions.
Yeah, I know you have a hard stop, but do you have time for a few questions? Or
I got about 10 minutes for questions.
All right, so I'm just going to read them as they're stated, and what I'm going to do as well, just so everyone knows, is Brandon, you'll get a list of all of the questions that were posted today.
Yeah.
Some of which we were able to get to, some of which we will not be able to get to. Sometimes you have to kind of skip over the ones that will probably take a longer response just for time's sake, but you'll get those shortly because we'll need time to close as well. So
I'll try to respond to as many of those as I can.
Okay, great. So what happens to the data that's later inserted that does not exist in the partition function?
In the partition function, it's going to go into the last partition.
Okay.
So for example, if we're partitioning on date, and in my case, I was doing, all of 1 month one bucket per month for all of 2013.
Okay.
All 2014 data is going to go in the December bucket.
Mm-hmm.
The December 2013 bucket. And that's when we might want to split the partition.
Gotcha. So what things should I consider when adding an index on a partition view?
Generally, I would find out if there are any development ETL processes that are going to use that table. That, in other words, are they splitting, merging, or switching partitions? You want to be aware of that because they need to add that into their processes. In addition, you generally want to align your indexes.
Okay. So go ahead.
That will keep the data, the indexes, with the actual table data, so it'll be a faster lookup.
Great. So after performing a switch from one table to another, the former table no longer contains that partition, asking as a confirmation.
Yes and no. So what actually happens is the data is assigned to the new table. The pages are just kind of unhooked and rehooked. It's like a detach and reattach of a database, except it's just that chunk of data. However, there is still a partition there for the, it's just an empty partition now on the old table. So it essentially will create a new bucket just kind of behind the scenes that you can plop data into.
All right.
What else have we got?
Yeah, I'm looking through them. Some of the questions seem pretty detailed. Probably not something we have in just a minute or so.
I can always try to respond to additional questions over the next couple days too.
Yeah, that's fine. Let me give you this last one. So I think you can knock this out fairly quickly. So we use XIO storage for our database server, which is a big storage, and it maintains data movement using its own controller, right? Would it be helpful to create different file groups for each partition, or should it be inside the same file group?
So what I'm assuming is it is a tiered storage system. We use a component here. You know, we have a bank of 15K disks. We have a bank of 10K.
Right.
You know, 7,200 RPM disks. It really depends. I mean, a lot of those systems, they're already going to take parts of your data, and they're going to migrate it up into faster storage as it is. However, if you find that's not happening optimally, yes, you can partition your table and have it send it to different file groups, and then pin the files in that file group to a specific tier of storage. I hope that answers the question.
All right. And I think for time's sake, we probably need to go ahead and wrap it up. So I'd like to thank everybody for attending today's event, and remind you that the recorded session will be posted to the archive section at the DBA Fundamentals website. We'll also post any contact information, presentation material, as well as any other information that Brandon would like to include on the archive. So that's http://fundamentals.sqlpass.org. I'd like to say congratulations to Madison, who is today's winner of the $25 Amazon gift card, and of course to Brandon. We really enjoyed the presentation today. I really, I'd like to thank you for giving it to the group. I thought it was great. I loved it. So, and again, I'll send you a list of questions from today's meeting. And obviously, if you have time over the next couple of days, like you said, maybe you'll be able to hit a couple of them. But anyway, thanks again to Brandon and to all the group members, and I hope that everybody has a wonderful rest of the day.
All right. Thank you. And if anyone wants to email me, my email address is the same as my Twitter handle. It's just brandon@sqlservernerd.com.
Awesome. Thanks a lot, Brandon. Appreciate it, man. You have a great day.
All right. You too.
Take care, everyone.